Hi all, this is the guided practice problems from section 20, number 21 from section 5.6. We are solving exponential and logarithmic functions today. And so we are able to use the opposite function or the inverse function to solve our different equations. So we're going to use, for number one, common logs to solve this one. So the first thing I'm going to do is I'm going to take the log of both sides. Okay. Now I'm going to use my log properties next. I'm going to take this negative x squared down in front. So that's going to give me negative x squared times the log of 3 equals the log of 7. And then I'm going to get the x squared by itself. So I'm going to divide by both the negative out front and the log of 3. And that's going to give me x squared equals negative log 7 divided by log 3. And then the last thing I'm going to do to get my x by itself is to take the square root and take positive negative. So what we would end up here with x equals positive negative square root of negative log 7 over log 3. Now this looks a little skeptical, but we're going to see what happens here. So let's try to see if we can figure out what number this is. So let's first start with this. Let's take the negative log of, did we say 7 or 3 comes first? 7 on top. Log of 7 divided by log 3. I probably have to put parentheses here. Just going to see if it worked without it. And I get negative 1.77. So that means I'm going to have plus or minus the square root of negative 1.77. And I don't know about you, but I don't know what to do with this negative. We would have to take an I out of there, which means there are no real solutions. Okay, so it is possible you get something that doesn't work. Okay. All right, next, let's solve this one using common logarithms. So this one's a little bit more involved. We got more things going on in the exponents, but the process is the same. Start by taking the log of both sides. Let's take our exponents out front. That gives us 5x plus 3 times the log of 2. And 2x plus 1 times the log of 3. Then let's go ahead and distribute. That's going to give us 5 log 2 times x plus 3 log 2. Over on this side, we have 2 log 3 times x plus log 3. Now let's move things around. So I want to put my logs on the left, so I'm going to subtract 2 log 3 times x from both sides. And I'm going to move the things that do not have x's to the right. So I'm going to subtract 3 log 2 from both sides. By the way, if you wanted to, you could always move these numbers that are out in front up as powers, but for me, it doesn't really matter. All right, these two cancel and we get 5 log 5 times x minus 2 log 3 times x. And on the right, these two cancel and we have log of 3 minus 3 log 2. From here, in this first, on the left-hand side, I've got 2 x's. I'm going to go ahead and factor that out. And log 3 minus 3 log 2 on the right. And now I can go ahead and divide by everything that's in those parentheses. And that leaves you with your x. So x is equal to log of 3 minus 3 log 2 all over 5 log 5 minus 2 log 3. And we can go ahead and put that into our calculator and get a value for that. So we've got log of 3 minus, oh man, I forget what it is, 3 log 2. Close your parentheses, divide by, open your parentheses. And our bottom is 5 log 5 minus 2 log 3. Close my parentheses, and we get negative 0.168. Okay. Okay. We can also solve using natural logs. So in this case, we're going to start out in exactly the same place, only instead of taking a log of both sides, we're going to take the natural log of both sides. And we're going to take this exponent and move it down in front. That's 5 minus x times the natural log of 2 equals the natural log of 6. Then we can go ahead and distribute this to get 5 natural log of 2 minus x times the natural log of 2. It does not matter whether you put your number, the natural log, in front or behind the x. It's totally up to you on that one. I'm going to go ahead and move the 5 ln 2 to the other side because it does not have an x and only have one term that has an x. And that's going to leave me with negative x ln 2 equals ln 6 minus 5 ln 2. Then, to get my x by itself, I'm going to distribute by the divide by the negative and the natural log of 2. And that means that my x is the natural log of 6 minus 5 natural log of 2 divided by negative natural log of 2. And we can go ahead and calculate that. So ln of 6 minus 5 ln 2. Close my parentheses. Oh, I don't want b. Divided by negative ln 2. Oh, gave it to me right there. 2.42. Okay. All right, same kind of thing. Use our natural logs here. So we're going to take the natural log of both sides. Take my exponent and bring it down in front. So 4x minus 1 times the natural log of 3. Distribute that across both. So 4 natural log of 3 times x minus the natural log of 3 equals the natural log of 5. Let's add that natural log of 3 to the other side. And we have 4 ln 3 times x equals ln 5 plus ln 3. And then we want the x by itself, so let's divide by the 4 and the ln 3. And that'll leave us with x equals ln 5 plus ln 3 over 4 ln 3. And if we want a value for that, we can do that as well. So we have, ln 5 plus ln 3. There we go. So we want ln 5 plus ln, no, we don't want that. 3 divided by 4 ln 3. And we get 0.616. Okay. All right, last two logarithm equations that we're going to use ease to solve. Okay, so again, idea here is to collect your logarithms. So subtract this log from both sides. So we have the log of, now you're subtracting two logs, so the one that's positive goes on top, the one on the bottom, the one that's negative goes on the bottom, and we just have a 2 left over here. Now, if I want to get rid of that log has base 10, so I can raise both, take the 10 of both sides, right? Raise both as the powers of 10. That way my log and my 10 cancel out, and we get x plus 1 over 3x minus 2 equals 10 squared, which is 100. Then we're going to go ahead and multiply by your denominator, so times 3x minus 2. On the left-hand side, they cancel, and we just get x plus 1. And on the right, we have 300x minus 200. And let's add the 200 to both sides and subtract the x. That's going to give us 201 on the left and 299x on the right. And then we want to divide both sides by 299. And so your x is equal to 201 divided by 299. Okay, which is a funky fraction, but still correct. Okay, same kind of thing here. Okay, in number 6, we're going to collect all our logarithms. So let's see. This should have parentheses here. All right, let's see. I'm going to put this 3 up here, and actually, yes, let's do that. Let's do exactly that. So put our 3 up there. We're going to take our 2 and put it up here. So that's going to give me the natural log of x plus 3 squared. And actually, I'm not going to move anything. I'm going to leave it as it is. And make this the natural log of 2 cubed, which would be 8. Okay. Now, on the right-hand side, these two things are subtracted. So if I want to put them back together as a big logarithm, the positive one goes in the numerator and the negative one goes in the denominator. And now, because I have the natural log on both sides, I can take the e of both sides, and those will cancel out. And so it cancels on both sides. And that's going to leave me with x plus 3 squared, which is x squared plus 6x plus 9. All over x plus 1 has to be equal to 8. So let's multiply both sides by x plus 1. And that's going to cancel my x plus 1's on the left. So I'll have x squared plus 6x plus 9. And on the right, I have 8x plus 8. And this is quadratic because we have an x squared. So let's go ahead and move everything to one side to make it equal to 0. So subtract 8x and 8. And that's going to leave me with x squared minus 2x plus 1 equals 0. And that can actually be factored as x and x, -1 and -1, right? Two numbers that multiply to 1 but add to -2. And that means you get x equals 1 twice. Okay, quick check to make sure that that works. If you plug in 1, if you plug 1 in here, that gives you the natural log of 4. Over here, that's the natural log of 2. So there is no issue with plugging in our 1. But we do always want to check.